Okay, so here's my iMaths on conditional probability. Question 1, it says to get a driving license you have to pass a theory test and a practical test. The probability that Joe passes his theory test is 0.8. So in the tree diagram he's got a 0.8 chance of passing. I can put that in there. Theory test, so there's two levels to this tree diagram. The first level is what he gets in the theory test, pass or fail, and then the practical test. So you can pass the theory, pass the practical, pass theory, fail practical, or fail pass, fail fail. So the probability that Joe passes his theory test is 0.8. So I filled that in. Then immediately we can fill in that the probability that he fails his theory test is 0.2, because that's covering all of the possibilities, and then it adds up to 1. So all of the possibilities being covered, their probabilities, as long as they're mutually exclusive from each other, should add up to 1. Okay, if he passes the theory test, so we go up here on the tree where he passes the theory test, then he has a 0.7 chance of passing his practical. So I'll fill in 0.7 for the chance of him passing his practical if he passes the theory. And if it's a 0.7 chance of passing the practical in that circumstance, then it must be a 0.3 chance of failing, so that the two add up to 1. Otherwise, his chance of passing the practical is only 0.3. So if he fails the theory, his chance of passing the practical is 0.3. So a 0.3 goes in there for that. And then if he fails, there's a 0.3 chance of passing. Therefore, if he fails, there's a 0.7 chance of failing the practical as well. So fill in the tree diagram. We've done that. Then it says, find the probability that he gets his driving license. Well, that can only happen if he passes both. So that's going to be 0.8 times 0.7 for both of those happening. So 0.8 times 0.7 is 0.56, and that one's done. Given that he fails to get his driving license, find the probability that he failed because of his practical only. Okay, so I've sketched that out, tree diagram very roughly, and I've written the conditional probability formula as it applies to this. So the probability that he fails the practical only, given that he failed the test, is the probability that he fails the practical only and also fails the test, divided by the probability that he fails the test in any way whatsoever. So the top bit of this, the probability that he fails the practical and also fails the test, so fails the practical only and also fails the test, that can only happen in one way. It can only happen where he's passing the theory and failing the practical. That's the only way that he can fail the practical only and fail the test as well. So it doesn't include the event where he fails both the theory and the practical. So the top bit of this is just 0.8 times 0.3, where he fails the practical and also fails the test. So 0.8 times 0.3 is 0.24. And now then on the bottom, we want the probability that he fails the test in any way whatsoever. Well, that can actually happen in 3 ways, because he can pass the theory and fail the test, 0.8 times 0.3, or he can fail the theory and pass the practical, 0.2 times 0.3. Let's just put some brackets around here. 0.2 times 0.3. Or, of course, he could fail both, the theory and the practical. 0.2 times 0.7, that way. 0.2 times 0.7, that way. So let's just multiply some of these out. 0.8 times 0.3 is 0.24, and we saw that on the top of the fraction. 0.2 times 0.3 is 0.06, and 0.2 times 0.7 is 0.14. So the whole bottom of that fraction comes to 0.3, 0.44. So the probability that he fails the practical only, given that he failed the test in some way, is 0.24 out of 0.44, which is the same as 24 out of 44, which is the same as 12 out of 22, which is the same as 6 out of 11. That reduces to. So 6 out of 11. So let's go back to the My iMaths. Okay, so the answer was 6/11. 6 divided by 11. Wants it as a decimal to 2 decimal places. So as a decimal, it comes to 0.545454 recurring, which rounds to 0.55. So the answer to that should be 0.55. Let's mark it. And there we are.